Welcome back, Focus Learners. Today, we are breaking down a truly foundational topic in modern coding by diving into an explainer on Lecture 38 by Skip Uni. Our goal today is actually pretty simple, but it is incredibly powerful. We're going to completely demystify the core tools of modern C++ development. So let's get right into it. If you're out there searching for a comprehensive C++ STL tutorial, well, you're exactly in the right place. And you might be wondering, why is this so important? Because mastering STL in C++, or the standard template library in C++ to use its full name, is literally your secret weapon. It is the absolute key to acing those technical interviews, passing company placement exams, and really thriving in competitive programming. Once you know how to properly deploy STL containers, algorithms, and iterators in C++, you basically stop reinventing the wheel and you start writing highly efficient, professional code. Okay, here's our quick roadmap for today. First, an intro to the C++ STL. Second, decoding the STL name. Third, containers, your dynamic storage. Fourth, algorithms, which are your pre-built action tools. Fifth, iterators for navigating the data. And finally, number 6, we'll pull it all together into the big picture. Let's start with Section 1, Introduction to the C++ STL, basically the origin story. Take a look at this timeline here. Pre-1998, developers were stuck relying on standard C++ arrays. And, they're strictly homogeneous, and they rely on static memory, meaning, well, they're incredibly rigid. You literally had to know exactly how much space you needed right from the very start. But then came 1998, which was a massive turning point. The STL was officially introduced in the C++ 98 version, and it brought these much-needed dynamic, flexible solutions. Fast forward to the present day, it is an absolute fundamental requirement if you want to compete at a high level. Moving on to Section 2, Decoding the STL name. Standard Template Library. So what does that actually mean? First, the word template. In C++, a template just means generic code. It's written in a generalized way so that it seamlessly works across virtually any underlying data type. You aren't sitting there writing one function for integers and then a totally separate one for text. Second, the word library. A library is simply a collection of predefined reusable code components. It means you never have to waste your time writing complex data structures completely from scratch. And this brilliantly illustrates the core philosophy of the whole thing. Think about the algebra analogy provided in our source lecture. In algebra, you use variables like x and y to perform operations without even knowing the exact numbers. Well, STL does the exact same thing for programming. It allows you to perform highly complex operations on various data structures, regardless of whether you're feeding it integers, strings, or totally complex objects. It just abstracts the data type away, letting you focus on the actual logic. Let's jump to Section 3, Containers, your dynamic storage. To really lock this concept into your memory, the instructor uses this fantastic physical analogy. Just think of large physical drums used to store oil or ghee. A container in C++ serves the exact same purpose. It's just a data structure specifically meant to hold, manage, and organize collections of data. You're basically just pouring your data into a secure, structured vessel so you can easily access it later. Now, why use these new containers instead of those old arrays we talked about? Well, standard arrays are static and homogeneous. Like we said, they're completely rigid. STL containers, on the other hand, automatically adapt to your specific storage requirements right on the fly. If you add more data, they just expand. This kind of flexibility is honestly non-negotiable in modern development. Let's look at how this builds out your toolkit. Based on what your specific application needs, the STL gives you several specialized containers. You've got vectors, which are your dynamic alternative to static arrays, lists, which are great for mixed data types, and hey, if you know Python, this is going to feel super familiar. Sets, perfect for unique elements and math operations. Maps, which are incredibly efficient for unstructured key-value pairs. And then other specialized containers like dequeues. You literally just pick the right drum for the oil you're storing. All right, Section 4, Algorithms, your pre-built action tools. 60 plus, that is a massive number. The STL doesn't just give you 2 or 3 basic functions to play with. It provides a massive library of over 60 predefined, highly optimized algorithms that are just waiting and ready for action. Instead of sitting there writing complex sorting logic from scratch and, let's be real, inevitably creating bugs, you just call these built-in algorithms. Need to arrange data? Just call sort. Need to find something? Use binary search. Need to shift elements around? Use rotate. A single line of code literally replaces hours of frustration.
Section 5. Iterators navigating the data. To really understand iterators, we kind of need to compare them to standard pointers. You likely already know that standard pointers simply point to general memory locations in your computer. Well, iterators act very similarly to those pointers, but they come with a distinct superpower. They are specifically designed and optimized to navigate STL data structures. They know exactly how vectors, lists, sets, and maps are built underneath, which allows them to work seamlessly across all of them.
You can actually think of iterators as the connective tissue of the STL. If you need to traverse or move from one element to the next inside a container, you use an iterator to point to those specific memory locations. They allow your algorithms to just glide smoothly through your containers, element by element, executing tasks without breaking the underlying structure.
And finally, Section 6, the big picture. Let's bring it all together.
So the really crucial point here is how beautifully these three components work together. Containers are your dynamic storage, right? Like physical drums. Algorithms are your operations, those predefined actions. And iterators are your specialized pointers, allowing those algorithms to safely traverse the containers. By understanding this trio, you completely upgrade your efficiency. You're writing less code, but that code is infinitely more powerful and adaptable. And that brings us to the end of today's high-level overview. The instructor in Lecture 38 promises that upcoming lessons will break down exactly how to implement and use each of these components with detailed real-life examples. So I want to leave you with a question to think about. Now that you have a firm grasp of the big picture, which STL component are you most excited to implement first? Think about a project you're working on right now. Could a vector, a set, or a pre-built sorting algorithm save you hours of work? Keep that in mind as you continue your learning journey. Thank you so much for joining me today on this explainer. Keep up the fantastic focus and happy coding.